Hi, how are you?
Good. How are you?
I'm doing good too. I can see the end there.
I know, so close.
And I like the
Sorry.
week was really short too. So,
I know, right? It's
how
nice.
is that your baby?
Yes, that is. He's decided bed is not cool tonight. Okay, hi.
Hi, is it your youngest?
Yep.
So you get to help mommy do her homework tonight.
Oh, yeah. So fun. Anyways, we'll pretend like he isn't here.
That's fine. I'm visiting my sister and I have my other brother and they have twins, so it's been fun having twins around and they're two, so all around you.
Nice. Nice.
So I believe I'm starting this week. So let me see.
Okay, go for it.
So define allele and describe how allele traits are expressed. So an allele is an alternative form of a gene that is located at a specific position on a specific chromosome. And so for allele traits are expressed when the trait is detectable or when the allele is dominant or recessive. The trait of a dominant allele is expressed if both or only one chromosome in a pair carries it. And for the trait of a recessive allele, it can only be expressed if both chromosomes in a pair carry them. There's also some exceptions. In codominance, we have both alleles that are active and both traits are expressed at the same time. That's all the book mentioned for the exceptions. Do you have anything else? Or any questions?
I think you covered it.
Okay. Oops. Where did my thing go? There we go. So next questions I had to describe the process of sex-linked inheritance. So in humans and other mammals, we have biological sex is determined by a pair of sex chromosomes, XY in males and XX in females. And genes on the X chromosome are said to be X-linked. And they have distinctive inheritance patterns because they're in different numbers in females and males. In a woman who carries 2 X chromosomes, if she inherits the allele for condition, the allele on her other X chromosome can overpower the recessive allele. She can carry the trait, but she won't be able to. She won't exhibit any symptoms. In a man who carries only 1 X chromosome, he doesn't have a dominant allele to overpower the X-linked recessive trait, and so he will exhibit the symptoms. Did you have anything else to add to the process of X-linked?
Nope, I've seen stuff I had there. So.
And the last one was to describe the process of autosomal dominant and autosomal recessive inheritance. So in autosomal dominant inheritance, a person affected by an autosomal dominant disorder has a 50% chance of passing the mutated gene to each child. And the chance that the child will not inherit the mutated gene is also 50%. But then we have, in some cases where the autosomal dominant disorder results from a new mutation that occurs during the formation of an egg or sperm cells. And in these cases, the child's parents are unaffected, but the child may pass on the condition to his or her own children. For autosomal recessive inheritance, we have two unaffected people who each carry one copy of the mutated gene for an autosomal recessive disorder, and so has a 25% chance with pregnancy of having a child affected by the disorder. And then the chance with each pregnancy of having an unaffected child who is a carrier of the disorder is 50%. And the chance that the child will not have the disorder and will not be a carrier is 25%. And that's it.
Awesome. Sounds good.
Okay.
Okay. And I got a book. My answers are kind of short on this, but I'm sorry. So, grab the theory of evolution. So I have here, according to the website, evolution is basically descent modification. The idea is that we're all common ancestor. And then it talked about small scale evolution, large scale evolution. Under this small scale involves an allele frequency of the population from one generation to the next. Large scale evolution of different species on a ancestor, many generations. That's what I had for the theory of evolution. That's what it was. It was that we all have a common ancestor, and that, you know, over time the genes we'll get a different allele that we pass on, whatever. Yeah.
Great, thanks.
Did you have anything to add to that?
No, that's pretty much what I've got too.
Okay. And then next was describe the process of natural selection and how it can lead to genetic changes in the population of organisms. So natural selection, I talked about that before, but it's the ability of a trait or traits in a species to survive over another due to genetic factors that make that species better able to survive. So I know they gave the beetles examples in there. There was the brown ones and the green ones. And in their example, I guess, the green ones, the green ones were more easily spotted by the prey, so they were eaten. So obviously more of the brown ones were able to procreate, make babies, and so over time it was more brown than green. Basically, maybe brown there. So I think it's just whatever traits are more suited to survival will survive. Do you have anything to add to that?
No, that was it.
Okay. And then the last one, this is my longer one. Describe blind evidence that supports the theory of evolution. So first I have fossil evidence. Basically we have fossils that show that there were animals in the past that aren't here today. And it also shows us similarities between species then and now that can provide clues to how they evolved and who their common ancestors are in their transitional forms of fossils that show the intermediate states between the ancestral form and that of the descendants today. Next we had homologies, where you look at similar characteristics, like you get due to relatedness. And they can be seen by comparing different living things and looking for similarities. It's the study of development, cellular evidence, the anatomy of different living things. Basically, look for similarities. So you study all living things today. And then the third one was distribution in time and space. This involves looking far into the past and considering, I guess, how the land was set up back then. We had larger, more consolidated land masses. We had Scythia and whatever the large breakup is called. So you can see different species or similar species on different continents. And then there's relative and numerical dating that can help understand the age of the Earth and different species. And by studying the layers of rock, we can use relative dating to help us determine the relative age of a fossil based on the age of the rock. And there's numerical dating. Basically, you look at the decay of radioactive elements, these rock, sand, fossils. So that was all distribution times space. And the next line of evidence is evidence by example. So we have the study of present-day organisms to better understand what has happened in the past. So looking at the interaction of populations and ecosystems gives us an understanding of how they may have developed over time. Artificial selection, such as through breeding or crossbreeding of plants or animals, can provide a model for natural selection.
Thank you. I skipped a few of them, so I added them to my list.
It was kind of weird. You had to search a lot through that because that was a lot on that website.
Yeah, you have to go. Well, thank you for covering these. And that's it, because we don't have anything else for this week for the exam.
Okay. Awesome. And do we meet next week? We don't meet next week, do we?
No, we only have the final for next week. Well, thank you for meeting and being my partner this semester.
Yeah, thanks for being my partner and meeting at weird times with me.
Yeah, that worked for me too. So,
awesome.
Well, good luck for good luck for the final and the exams. Take care.
Okay, you too. Bye.